SUHAY Plus,
Smarter urban hydroponics via AI monitoring and generative feedback for improved agricultural yield.
As we all know, urbanization in the Philippines has been growing very fast, and right now, about 42% of Filipino peoples now lives in cities, and this number will continue to rise. Because of this, farmlands are now being replaced by infrastructures and buildings. This causes problems like less food production, pollution, and loss of farmlands. According to the Department of Agriculture, about 10 to 20% of city lands can actually be used for food production. However, it remains unused due to lack of technologies and supports. One of the promising solutions to this problem is hydroponics, a way of growing plants without using soil, using water with nutrients. Hydroponics is very important and effective in cities where traditional farming is not possible. This led to the creation of Project SUHAY, which uses AI with camera to check the health plants through their leaves. The AI system is upgraded with ChatGPT for better image recognition. Our study focuses on three major areas, which are the software, hardware, and general performance. Our study also focuses on three set of engineering goals, which are the monitoring, generating health feedback, and enhancing accessibility and automation. Our study is significant because it contributes to the following groups, which are the urban farmers, students, communities, and future researchers.
Now moving forward to the methodology part. Our study, Project SUHAY Plus, utilizes a quantitative research design to evaluate its performance. For the materials, the electrical components that we highly utilize are the ESP32, solar panel, lithium-ion battery, web camera, water pump, water level sensor, and for the hydroponics parts, we used a grow box consisting of styro cups, cockpit, and vermicast, lettuce, pechay, kangkong, and mustasa for seeds, and 2 super blend fertilizers. The figures shown are the 3D design of the prior model of the prototype itself, the circuit design on how the electrical components are connected to each other, the program of the prototype using the C++ language, and the flow of algorithm on how the prototypes works. Now moving forward to the step-by-step procedure or methodology of the creation of the prototype. The first one will be the fabrication method, which involves the skeleton construction of the base of the prototype itself, the installation of the hydroponic system for the plants, the installation of electronic components for the system itself, and mounting of a web camera, which involves the angle and the distance of itself from the grow box. Now moving forward to the system testing, we have two, the initial testing and the actual testing. For the initial testing, this is to guarantee that each materials involved are working properly and accordingly, while the actual testing we have 5. The first one will be the blink system activation, the application for monitoring. The second one will be the manual image capture process, adjusting the system for the prototype needs. The third one will be the frame-based image analysis, whether the system works properly and can identify its objectives. The fourth one will be the system feedback and interpretation, whether the ChatGPT works and the application can respond. Now for the last part, we have the data logging, recording the data for system checking. Now for the evaluation, we use a proposal sampling, collecting 10 electronic engineers and 5 agriculturists.
And for the risk and safety, the experimentation may include the following risks, which are from the process of creating the prototype and as well as conducting the testings themselves. This includes the usage of handy electrical components that may also lead to short circuits. The assembly and testing would also be following strict protocols, such as proper chemical handling and the correct waste disposal. And with the guidance of their qualified scientists, they conducted a study with care and safety. And as the means of safety procedures, they use safety equipment like safety gloves or hand gloves for the protection against the mentioned risk factors. Now for the disposal, the organic plant waste will be repurposed for agricultural use, which focuses on natural composting for its environmental factors, while the electronic e-waste will be properly disposed through authorized e-waste recycling programs. Now on to the data collection. The researchers conducted a survey for approximately 15 respondents. This includes 10 electronic engineers and 5 agriculturists, using the Hero6-based survey format, finding its ungroup median with a 4-point Likert scale interpretation. The participants evaluated the hardware, software, and general performance of the Project SUHAY Plus prototype. They evaluated through the Google Forms survey and as well as the face-to-face survey evaluation.
After the procedure comes the result. First is subproblem 1, which is the hardware performance that produced a median score feedback of 3, meaning good. This also indicates that the prototype has a stable structure and reliable system. Second is subproblem 2, software performance that gave a median score of 4, which means very good based on the criteria, and indicates that the AI's monitoring, image processing, and control and user interface is very outstanding.
Project SUHAY Plus proved to be effective in meeting its engineering goals. With a hardware rating of 3, the prototype showed strong structural design mobility, and software performance rated 4 demonstrated high accuracy and reliability in AI-based monitoring and image processing. Overall, the project achieved a general performance rating of 3.5, highlighting its effectiveness in promoting plant group. In conclusion, with continuous hardware and software improvements, Project SUHAY Plus has the potential to become a scalable and impactful solution for advancing modern sustainable farming and addressing real-world agricultural challenges.
And now for the future researchers who would want to continue and expand this study, the researchers recommend you to number 1, nutrient comparison, which is to compare much more nutrients and fertilizers that can also differ the results. Number 2 is expanded observation. This is to much more observe what the plant's health would be. Number 3 is environmental variations. This is to put the plant into various environmental conditions which can also affect the result. And lastly, it is to add pest detection, which includes adding sensors to remove pests or avoid pests from going to the plant.